som är trusted.
So, good morning. So you guys should now be largely busy with assignments anyway, and now in the next few sessions we probably have topics that are kind of lateral related, right? That go beyond what you need for your assignment, for example, but also to expose you of particular use cases or problems or challenges and so on. So on Monday, Ahmed, for example, will be talking about the idea of using computer vision and linking this as a mechanism, or using it as a mechanism for input generation. So if you want to interact with your program, whether or not it has graphics output, you can still use computer vision techniques, which are kind of the complement to graphics in that they process input graphics, whereas we're producing output as graphics, right? So it's not directly related, but I think it's still an insight, interesting insight for you guys, perhaps, and perhaps produces some thoughts or ideas of how you can use it in your work, perhaps even in your assignment. The week after that, I talked to Per Morten. He's will probably come in again and talk about his experience in terms of, to some extent, writing a good baseline architecture for the game engine that he used in the exam. So I think it's a worthwhile talk to have. So especially since you are in a similar position to prepare yourself and bring any code you want, or use any code you want, really, as long as it's largely done by yourself for the exam. So I think that's quite helpful for you as well. But before we get there, one topic that is still part of the original curriculum, but so it motivates some of the different elements, is animations, because we did graphics without animations so far. Or did we? Did we do animations?
Sprite animation.
Ah, very good. So we did animation. So we're actually good. So, but still, we need to get a bit of more depth inside. And finally, the coffee is coming. That's good as well. So, So anyway, animation. So just to provide an overview, because it's quite relevant as well, to just recall that again, this lecture is always history lecture to some extent. There's a wide range of different APIs, and many of them support animations the way you want it and have seen it, especially using sprite sheets in a 2D context. Those are some of them, right? So some of you explored SDL. Some of them briefly saw it in one lab, I believe, and then we abandoned it quickly. But it's actually quite powerful as a 2D, particularly for 2D applications. So, but apart from this, even in the classical operating systems or programming languages like Java, there was always a 2D API that was focused on fast calls, but had a lot of the features that we need, for example, for animation or for interaction. Similarly, there are some other engines such as Talk2D, which has been made de facto publicly available. But I'm not sure how heavily it's used nowadays, but it was quite popular amongst for ad hoc game making in a student context or in a startup context, just to prototype basically a game situation. So, of course, if you write any game, Flash is apparently dead. Who didn't know that yet? Okay, just checking. But there are still quite some APIs out there that you can actually use. And the question is actually, what do you need to support in an API to have a gameplay experience and basically manage your basically to manage your game interaction largely. What are the features that you definitely want to see in a game engine if you develop one for yourself or in an API? So you guys are now developing the second assignment, and you probably should start seeing some patterns there, right? What are the kind of features that are recurrent? What are the kind of features you kind of throw away every time you start over? So any intuitions?
general structure or like specific features?
Well, specific features. So, yep.
Well, input from, for example, gamepads.
Okay. Yep. Some input from different input devices and so on. So what you're probably talking about is having an input interface, right, in a wider sense, right? Yeah. Because you don't want to tie yourself down to gamepads only, for example, right? So possibly anything that can manipulate your X, Y, and Z coordinates will probably do, right? So providing those in some sort of form. Anything else?
Can you do that by whistling and then figuring out the pitch and then moving it based on that?
Cool, but is that generic, that use case?
No.
No, it's not. So let's stick to the generic bit. It's good, but it's probably not like something you would expect from any engine. Please.
Classes that relate to specific terms in modeling, for instance, such as mesh or model or vertex. You might want to make that with those in advance, or like have a uses those terms.
Okay, so you want your engine to use the terms as they are used in practice. Is that what you suggest?
Yeah, like or have an API that uses those terms.
Right. Okay. Yeah. Okay. So you're kind of linking theory to practice in a way, or to the use case of the system, if I get this right.
Those are things that you don't need to do again and again every time you make a new project.
This is precisely what I'm asking for. Exactly. What's the kind of stuff you want to have supported, so you don't need to do it again and again for every project, yet it's always the same, right? So yes. So having window management. Yep, that's a good one. Yep. What else?
Texture loading.
Yep.
Or resource loading in general.
Yep. Cool.
Audio.
Of course. What else? Didn't expect anything less. But no, that's right. Audio in principle. Yeah. You want to have some interface to deal with audio. Yeah. What else?
Some UI maybe.
Mm-hmm. Okay. And if you're thinking about some UI. So what's quite important as well, and it's very independent of the concrete use case in graphics. What else does the system need to be able to do?
Draw.
Yeah, and draw. Right, but what are the challenges in drawing? Is it just drawing, or what else do you want it to support? We talked about some concepts before, I think 2 or 3, probably 4 weeks ago now, where it's not just about drawing triangles and squares and cubes, but if you want to have more complex concepts, right? So how would you represent this, or what are the features?
An hierarchical structure of objects, so say scene graph.
So that would be a possible way, right? So suggesting that there's a support for that one. But even if not, you definitely want to have some sort of support for rotation functionality, scaling, translation, those kind of things, right? So it doesn't necessarily come naturally. You could write an engine that doesn't have any of those features. So you would need to consider this explicitly as well. But it's super generic, right? So it's like everyone would need it as soon as you deal with graphics. Yeah. What other thing did we talk about that probably should be supported in your engine?
Lighting?
Yes, lighting, of course, right? So we talk about different forms of lighting, and again, they are reasonably uniform, right? We have positional lighting, directional lighting, ambient lighting, and so on. So even there's not much divergence in terms of theory, right? So you can pick and choose and support them as part of the system. And of course, if you think about games more, something we don't really talk about explicitly too much, what's also very relevant, I think, to be considered?
Maybe like modeling, for instance, a scene or level, so you don't have
okay.
everything in the scene at one point.
Okay, that's a good feature. Yeah, that's good. So that's really game focused, having the concept of a level, some sort of structure that you can embed your gameplay in. Yes, that's right. But even independent from a game, let's say, and we have a 3D scene. But we want to use it as a game kind of interactive mechanism. What else do we often try to emulate? So if you think, yes, exactly, right? So you want to have again, as has been frequently mentioned here, graphics is all about cheating. So again, the physics also needs to be cheated somewhat into the system, right? So you have a realistic appearance of somebody running, for example, right? So, and the components involved in running are not too simple. It's not just moving from A to B, right? So it involves an animation. It possibly involves velocity. It probably, or it should involve some sort of acceleration and deceleration, right? So if you consider all those components, it becomes quickly much more complex. And of course, for other concepts such as collisions and so on, the realistic representation of physics is important. Otherwise, you will not the game will not appeal to you, right? So it will not be attractive to you as a user. So those are, you know, you can stack up different features and you can decide which are more important, less important, and so on. But ultimately, all those aspects kind of need to be considered, and some of which we had talked about, many of which we didn't, because they're obviously very game engine-y and not too relevant. But so. Yeah, so those would be, for example, some features that would be quite relevant. So thinking about aspects like layers of representation, but this is more geared towards 2D concepts here. Having layers of interaction and animation system is very important in the 2D area in particular, because you rely on it heavily, whereas in 3D you probably model it, you develop it yourself largely, because it doesn't necessarily rely on the framework so much, but rather on your chosen implementation for individual elements. But here it's really about moving object A from here to here in a given amount of time or whatever else. So a very standard kind of concepts, especially if you think about using sprites in those APIs. Yeah, so those would be some basic ideas. Why I'm doing this? Well, the idea is I want to encourage you to think about, okay, what do you possibly need for the exam, right? So we will talk about this more, of course, but I want you guys to slowly assemble all the things that you probably need to consider, since we talked about them, and you most likely used the concepts, yeah, for the exam, right? So to make your life a bit easier. So start thinking about having your framework ready, and that doesn't necessarily mean that you have a fully fledged framework with documentation and clean API and so on, but rather having the features ready so you can plug them in when and where you need them. Okay, coming back to animation, hopefully. So to make some progress there and get a bit of an intuition going. This talk is, let's say, 50% could be used from a designer perspective and 50% from a developer's perspective. So it sits a bit in between. So bear with me if you feel like, oops, are you really talking to us here? But we'll figure that out. So animation is all about changing images quickly, right? So you guys experienced that firsthand using the sprite sheet, the Prince of Persia emulation there, that you actually just moved pictures more or less quickly and got a appealing and seemingly fluent interaction with the system, and you had the perception of a walking or running person, right? In this case, the animation. How many types of animations did we have in this example in the sprite sheet we used?
Types?
Yep.
What do you mean by types?
So movement features that the guy had. Behavioral paths, if
vertical, horizontal.
No. No, it's more like if we think about animations, we think about this in semantic concepts such as running, sitting, walking, so and those would be animation paths, so you can have multiple of those attached to a particular object. How many did we have in the one, right? So which was? Walking or running. Either walking or running, right? So it's not clearly distinguishable because there was no explicit labeling, attached. Yeah, please? Stopping, yep, that's right. Cool, yep, that's right, absolutely right. So all those acceleration or deceleration movements can also be considered as those paths, right? Because they will be subsequently followed by, let's say, a running animation and so on. Yep, that's good. So, it's animation. It's all about timing, and that's quite important to realize. In that you basically give the user perception that something is fast moving or slow moving by changing the timing, and the timing is in relationship to the number of drawings you have as well, or number of frames that you have as well, right? So the more refined, more detailed your actual animation is, the slower it actually appears, right? If you draw all the frames, right? Because you have so many intermittent frames in there. Unless you omit some, then you can obviously have the same fast-moving pattern that you want to achieve eventually. But obviously, apart from looking at speed as such, there's a lot of, from a perception point of view, there's a lot of secondary aspects involved as well. So we, for example, perceive fast-moving objects somewhat lightweight by intuition. It may not necessarily be true, like, you know, think about plane and so on. But the idea is that if you, particularly in a game context and so on, you have this kind of concept, you are more inclined to think about a light object that moves particular speed, whereas more slow movement is conventionally associated with a more heavy body. Yes. So, and then we obviously have the challenges of making increasing the realism by actually having a, not just you know, running through the scene, for example, but actually by motivating it in a sense that we have some sort of acceleration and deceleration. But from a designer point of view, you even want to go further and actually also want to prepare the observer, for example, in an animation movie, if you like, but even in a game perhaps, for this particular movement. We get to that in a second. So it's quite important not to think only about the animation itself, but also how can we start and stop it without any disruption on the user perspective, right? So how does the user feel about it and how does it perceive it? So it's all about, yeah, please.
I don't think that it's specific enough to say slow movement, but maybe slow acceleration, which makes things feel heavy.
Yeah, anyway,
It's
yes, yeah.
Like a plane
Yeah.
still feels heavy because it takes a long time to turn it around if it's big plane. Small planes turn around slowly. But
That's
the biggest planes travel fastest.
Yes.
Almost.
But wouldn't you have, let's say, if you have an animation path, right? So, and you have a plane move, while it moves slowly, you could, you're pointing to a trajectory, right? It would use, for example, a larger, heavier plane would have a much wider trajectory in turning, right?
Yeah,
Compared to
slower acceleration.
Right, in deceleration. Yeah, that's a good point. That's right. Yeah. So that's our natural cues to see it. Yes. But yeah, that's right. So most of the concepts that we're talking about and so on are actually borrowed from Disney, right? Because they were the kings of early animation. They had developed or collected, established quite a bit of a knowledge base on how to do animation properly, because they literally need to draw every frame from hand in the beginning, right? So which is kind of tedious, expensive. So people actually sat down and think, okay, how can we make it as effective as possible to actually draw animations without having, needing to redo it again or disappointing the user, meaning having unrealistic situations. So there's quite some rules attached to that. While those principles apply generally to hand-drawn animations, so really frame by frame drawn individually. They're equally relevant for us here as well, so to some extent. We'll go through some of them, and I'll point you to a good little clip that you can watch to actually get a good overview of all the principles, and that's actually quite insightful. But of course, there are some differences with respect to the dynamics of environments as we are having them, right? So but we are actually able to do that all in our graphics framework, as opposed to needing to draw intermittent scenes, meaning we can interpolate between different frames and so on, things like that we can automate, which wasn't possible at that particular time. So at the core of everything is timing. So the idea is there that of course something needs to be timed right, meaning acceleration, deceleration need to match. But more interesting is that even though physics is important because it needs to follow our intuition, sometimes physics can be distorted in order to emphasize or engage the audience more. For example, here this bouncing ball idea is that the bouncing ball in this is the classical example. We hear about this in a bit more. It's about bounce and stretch. It's the idea that it actually changes shape, right? Which is inherently unrealistic, right? Because it wouldn't change shape in that very same, but probably would rather, perhaps have some deformation at this particular stage. But other than that, would be constant in its ball shape. But here the idea is, if we change the shape proactively, we can emphasize or exaggerate, that's probably a term to use here, the physics involved. And that gives a perception of a much more realistic movement from an animation point of view. What do you think are the properties of that ball, for example, by looking at this animation path?
I would go out on a limb here and say that it's probably bouncy.
That's good. That's that's bouncy. Yeah, but also is it hard or soft?
It's very soft.
Looks very soft, right? So you actually convey information about the material beyond the physics, right? So suddenly you know more about this particular ball. You assume it's super squashy and squishy and whatever else, right? Just by looking at that animation, independent of whether the physics are right or wrong, right? So in fact, the physics are about okay, but it's just the deformation that's off, right? But this is the kind of magic that Disney has introduced to actually have kind of secondary elements or features that convey information that you would otherwise not get, right? So we are basically conveying information from different domains at the same time. But the important thing is it's about appearance, and from a tester perspective or developer's perspective, it means you need to have some users look at it and actually ask them, hey, what do you think? Does it look realistic, right? So you're quickly in the area of user studies, because you don't need to rely on physics. Even if it's accurate, it may be like super unentertaining, right? Think about games. They usually, or many of those, I'm not sure if I still do it, but racing games, they usually had a simulation mode and a kart mode, right? You guys recall that to some extent?
Yes.
And it was really about having a realistic car racing simulation, right? Which is all the realism, and challenges which were usually considered hard, but also incredibly boring, because you constantly fly off the road because you don't get the physics right? The gauges, whereas the air kart one was much more richly animated and much more forgiving in terms of user interaction and things like this. So it's quite similar here. So how do you engage the user more, and how can the user perhaps even learn more about the car behavior without constantly flying off the road before you can even settle on the idea that you are racing a car? So this kind of same motivation here. One aspect in terms of timing or animation that's super important. That's the first thing we probably see, is the idea of continuity. And the questions there, you all have seen it. Horrible animations where you don't have a continuous path, right? So you may have sudden positional changes, or perhaps even jumps between different positions, right? So the animation is kind of a loop, but basically the start and end are not properly connected. So you have some kind of interruption there. So that would be the case of no continuity in that you suddenly, for example, have positional changes, right, which would imply infinite velocity, right? So suddenly you have an infinite shift there without any explicit representation of acceleration, meaning that when moving from this position to this position, you don't have any concept of acceleration between. It just happens that it's suddenly in a different position, right? So that would be the idea of having no continuity. So the minimum thing you want to think about when you create an animation is to ensure that it's somewhat smoothly and that you don't have sudden jumps between the object in the scene, right? So you want to have some sort of position continuity. So if you do this one, the idea is there that you solve the issue of connecting individual coordinates, for example, by shifting or by moving an object from coordinate A to coordinate B, but it still doesn't necessarily imply that you got the velocity right, because you may have still some sudden, let's say, either you don't accommodate the fact that you're actually following a path when moving, or the other case is that you are, so basically you don't accommodate the fact that you, for example, take a corner and the car should slow down and things like this. So you actually have a don't have a jump between different positions, but the velocity is unrealistic, right? The perceptual velocity, that's not how you would see an object behave in the natural and real environment. So, and then the last aspect is to actually how to deal with this acceleration problem. So how do you, because basically if you have, so if you introduce the idea of having a smooth acceleration, then you have a continuous smooth movement that would be considered physically realistic. That's the key idea there. So, so that's the idea. So you incrementally fix the problem from left to right. So if you have a disruption in different positions, you kind of need to figure out that you actually link this, ensure that the movement between those positions is somewhat smooth by balancing it out. But the problem is there that you may have suddenly a sudden increase in velocity. So suddenly your object speeds up and slows down again, but you don't actually have an acceleration concept in there. So, and this is where the higher level continuity comes in to actually not only deal with velocity, but also acceleration and deceleration. To motivate this a bit better, I found a quite neat clip, briefly, it's only 1 minute, that I just want to play and see. We have some sound. Is that all right?
Yeah.
It's just the levels of continuity.
Creates 3 different levels of continuity. The first one is no continuity, not even continuity of position. You can see that the yellow path is broken in the middle, so that when the car traverses it, at this point in the middle here, it seems to suddenly teleport. In fact, it does. This would
So it's no continuity, right? The first one.
Fictional setting. If we ensure continuity of position, but not continuity of velocity, then at the middle of the path, the car will suddenly change direction. Right here. This would only be appropriate if a collision or some other force impacted the car at that moment. If we don't want this to happen, we can ensure tangential continuity, that is, continuity of velocity. This path has no sudden changes in velocity, although at the middle point here, there is a sudden change of acceleration, but it's difficult to see. If we even wanted to remove that and make the car have perfectly smooth driving, we would ensure curvature continuity, that is, continuity of the second derivative of position. You'll notice that on this path, the car has very smooth driving. That's a subtle change, but you can ensure it with C2 continuity if you want to.
Yeah, so just to, it's just meant as a motivation for the different forms of continuity in animation, so that basically would be the difference between having a animation loop, for example, or this kind of scene appear realistic or unrealistic. So position, velocity, acceleration as the key. And the most obvious one is position or direction, as done in the example, and then having realistic velocity representations, and then smoothing everything by dealing with the acceleration as the last bit. So in conjunction with this one here, we're talking about path movements, for example, across the scene. It's also about what Jonas mentioned earlier, having a starting and stopping kind of movement, right? So the important thing is if we want to, for example, ensure that a character properly engages in running or stops from running or walking, that we kind of ease the individual or the player in and out of this one, right? So, and from a modeling point of view, you guys have been dealing with the Unreal Engine, I assume, or played around with this. So instead, or you will anyway, but the point is, you could obviously, when you model acceleration, deal with realistic physics, right? So have a realistic physics representation by representing force and applying this to current velocity, and in order to decelerate or accelerate. But the idea is they are that in most engines or modeling environments, you actually model the animation by using those kind of curves, right? Those Bezier curves that actually have a, this is a quite neat example. So you have a very slow increase in velocity, for example, and then you have some deceleration movement here as well before you actually stop, right? So you can model the easing process. So if you want to have a harsh or rough movement, so there's, yeah, so instead of just setting a, or immediately going to the maximum velocity, for example, when moving an object. So that's quite relevant to think about. So how do you actually deal with the realism of starting and stopping a movement in particular, right? So to have it show quite realistically. Many of those modeling tools have different form of default curves, but I think the most common was the Bezier curve that use any one of those here that you see there, that you have a very smooth and gentle start of the movement and corresponding end. So that's the idea behind the easing process. And it's really just to emulate the feel in the real physical world. But again, it's about perception. So you look at it and see if it feels good. If it feels good, then it's probably good enough for an animation, as opposed to being physically accurate. Yeah. So, of course, what does it boil down to is, if we see those curves here, okay, what do they tell us? If you have a given animation, it usually consists of a sequence of frames, right? So we have an animation consisting of 10 or 20 frames, so things like this. It just basically describes the timing of the frames, right? So frames at the beginning of a movement or frames at the end of a movement are played more, exchanged more densely, right? Played more. The time delay between, or time delta between individual frames is way, way smaller than it is, for example, for the middle range, where you have the running movement, right? So that's the actual impact you actually have. You just describe the time behavior across an entire animation path, right? So I draw this briefly. So we have frame 1, or let's say frame 1, frame 2, frame 3, frame 4. So the idea, and so on, the idea is that instead of having a, when playing it continuously, is that you actually just condense the initial first frames and afterwards having increasingly large deltas, right? So you probably need to make that a bit more explicit here. So the deltas are slowly increasing and becoming less dense. So this way you can use a continuous animation, or an animation that is modeled with equidistant frames, but nevertheless giving it an appearance as if there's an acceleration or deceleration in there, right? By changing the timing. So it's not necessarily about changing the animation or the frames behind it explicitly, but just the timing of them, right? So plus we have an advantage that even if we don't have enough information to, for example, to accommodate the large number of frames needed here, we can still use interpolation. So the idea is there basically let the computer calculate a frame that sits between those two frames that I have explicitly specified. Yeah, we'll get to that in a second. So that's not something that Disney people could do, so they actually need to draw it, but it's something we can do. Yeah. So in the case of animation.
So the curve representation is just to show the length.
The basically the timing, right? Yeah, timing between the individual frames of the animation. Please.
Explain why you suggest use curves rather than force calculations?
Because it's, because the idea is there that it's quick to adapt, right? So if you do the force calculation, you obviously apply the fixed acceleration, deceleration. But here you can quickly adjust and simply have a short feedback cycle and perceiving it, right? So you can see.
So you don't mean actually force it like in physics? Can you apply force to an object?
Yeah.
To move it?
Well, for example, if you accelerate, right, you have the effect of gravity, right? So which leads to the acceleration perception. So meaning you're not immediately at your target velocity, right? So but instead of calculating this explicitly, the idea is there, okay, how can we change the timing to make it appear as if this force was applied on the object, right? And then interactively play around with those curves. Particular Bezier curves, Bezier curves are quite amenable to this for this purpose, right? So the idea is that you have slow easing in and slow easing out of an acceleration. So having an acceleration phase here and a deceleration phase there, and then you can easily manipulate it until somebody says, "Yeah, it looks realistic," right? I sense you had something.
No, I was going to possess the same question because I got the impression impression you misunderstood what he said, but he didn't.
Okay.
So it's an alternative to a correct physics.
That's right. Again,
Because if you had a perfect physics
Yeah.
simulation, you wouldn't need animation
yes, that's right.
if it was perfect.
Yeah.
But it's so much more expensive.
Yes, you're on the one hand, you're perfectly right. On the other hand, I'll come back to this in a second. On the other hand, the problem or the challenge about animation, particularly in the original sense, is about, to some extent, its exaggeration, right? Because you want to motivate a movement more strongly, such as in the bouncing ball example. So the engagement with the actual object of interest is actually higher if you have possibly some unrealistic movement in there, but nevertheless, approximate the physical reality to some extent. Again, it's similar to the arcade and the simulation example, right? So if you see the real world in television as it is, it may not be as attractive or appealing for a player to engage in. But if you aim for realism, of course, this would be the perfect objective. But even think about first-person shooters and so on, right? So if there wasn't some fuzziness about targeting, for example, how many people would actually possibly play it, right? You would have a subset, a niche set of players that would really specialize in a given game because it's so incredibly realistic. But you need to make it accessible to people that may not be able to accommodate the necessary accuracy that you, for example, need to have an aim in reality and so on, right? So those kind of effects were. So it plays both with realism to some extent, but also with engagement, because it's about entertainment to some extent.
I mean, the curves, you could use them to change around whether you're using physics or using the
Yes.
animation as well.
Yes.
If you actually need some physics to do gameplay,
Yeah.
you'd maybe do both.
Yeah. Or your point is very good. Your point is very good. In fact, those curves are basically derived from physics, right? So they're like empirical movements that you find in terms of deceleration, acceleration. And here's your template, and now you can shift around to make it more engaging or not, right? So that kind of. But the problem is that a lot of this is very subjective in terms of assessment, right? So you look at it and see, oh, does it feel engaging or not, right? And that's where this interaction approach comes in. That's why most frameworks do it this way, that you get a feel for this easing process using curves. But yes, it's grounded in a physical, accurate representation, but more flexible, if you like, right? Because if you have your actual realistic physics representation, that's it. There's no need, like you say, there's no need for animation. Again, it's about approximating some sort of not only reality, but also engagement with the user. And to motivate this a bit more, especially this aspect of exaggeration, which I mentioned just now, I just want to really bring in the 12 principles of animation. They were actually brought up by a group of 9 old men. Those were the original drawers, or at least the ones responsible for drawing for the original animations of Disney. And they realized, okay, over drawing frames for a large number of years and having this issue of actually needing to literally draw every frame, with any sort of meaningful tool assistance, at least not automated. They realized, okay, we need to come up with patterns to minimize, wasted time, right? So if you draw animations, how are you quick and effective in doing this, and how are you most likely engaging the user? And when you look at those principles, you will find all the patterns you know from cartoons so to some extent again. I'll briefly go over them. I found a really nice video that motivates all of them, which I recommend you to watch, because it's kind of condensed. But I still try to retrace it from based on this motivation here. So the idea is there that you use squash and stretch. So the idea is, you saw the bouncing ball example I showed you like a few seconds ago, right? So, and the idea is, okay, can we change the perception of can you give the user a bit more context information by changing the animation by, for example, stretching an object or squashing it to some extent, right? So in this case, it conveys information about the mass and the properties of the object, so it makes you much more engaged with the environment. So timing and motion, that was along the lines of, you mentioned acceleration, deceleration before. How can we use this mechanism to actually give the user a perception of the properties, such as weight and size of a particular object, right? By having slow acceleration, slow deceleration, fast movement versus slow movement. Right? So that's the idea. Another aspect that is important in comics, probably not so much in an accurate representation, is the anticipation for an action. For example, now it comes. No, I can't draw that stuff. But for example, instead of if you, for example, have a running movement, right? So running from to a particular point, you find in comics there's usually some sort of accelerated motivation of the movement, right? Like taking up a momentum before you actually run, right? So you give the user a second before you actually shoot out of the picture, right? So your user knows what's coming to some extent, but kind of doesn't, right?
Spinning the feet in place. The character usually stays.
Ah, yes. Yes, having spinning feet in place, and you should see him shoot off. Precisely that, right? So that's one of those aspects of anticipation that you would could model. So, but of course, it aims at entertainment in this particular case.
No, it's very relevant in character animation, but that's not something we're doing here, but it is incredibly relevant there. Say, for example, in any game that includes like melee fighting, you have to, say for example, Dark Souls or any of the Souls games, you have to dodge attacks. The anticipation of the attack tells you what the player needs to do.
Yeah. Okay.
So it's incredibly important to win in games.
No, that's right. Yeah, you're right. In games as well. Yes.
Yeah.
I was thinking real world. So movie. There's the game film disparity because it comes from the film cast. But you're right. Of course. That's why we're talking about it. Games the same, right? So if you want, point is, in games, however, you need to check out, do I have the time to have this animation, right? So, sometimes it's about reaction, right? So you don't have time for anticipation, but your player character needs to respond immediately. But in this case,
you usually can't have anticipation on the player because the player needs to be incredibly responsive.
Exactly.
But like enemies can have tons of anticipation.
Yeah. Cues.
Yeah.
But this principle is borrowed from here, right? So whatever you find in those games as well, it's always comes back to those principles idea. So that's anticipation. I think the intuition fits well. Staging is about looking at a scene and systematically building up. So telling the user in a comic strip, for example, what to look at, right? So a classical example would be to use spotlights. Right, so you use spotlights and highlight a particular area, so the user is automatically guided to look into this particular direction, right? So especially if there's a lot of things going on in parallel on the scene, right? So staging is quite important, so people have actually time to concentrate on this. This one is probably not so relevant for you as animators really, but it's really more interesting for drawing, but I nevertheless left it in because the question is there. Okay, now I want to animate a particular movement, let's say a jump or running or and so on, right? So, and the question there was always, how do you actually draw it, right? So if you have a jumping motion, and don't worry, I'm not drawing. If you have a jumping motion from here to here, okay, do you model each incremental frame, right? So, no, I'm not. So, do you really model each incremental frame? So basically having the first pose here, I'm drawing. Okay, it works better than I thought. So you whatever, right? So the question is, do you model straight ahead action, so incremental model here, or do you just model the first pose and the end pose and then interpolate in between? Right? So because the problem is that it may suddenly appear unrealistic, or you're moving, you ending up in the wrong spots, or you there's some sort of path dependence that leads you to having an unrealistic perception, or you get the trajectory wrong. Suddenly it's looking like that, right? So the idea is there to solve this issue. The second technique would be referred to as pose to pose. So you have a starting pose, and you have a you change shape doing the jump. Anyway, and you have the end pose basically, and then you interpolate between, right? So you do once you decide, okay, that's actually a realistic start and end of a jump, right? So then you interpolate and add the individual frames in between. Yeah. So that would be pose to pose, whereas straight ahead action is the opposite. That's basically I'm literally modeling all the frames and hopefully I'm ending up in the right place. Yeah, so that's the kind of thing. So as far as I understand, the straight ahead action is generally preferable for things that are emergent, such as fire or fog and things like that. Because you don't have a dedicated end pose for fire, right? So it's kind of a continuous concept. So you just model the incremental changes in the flame, let's say, and then at some stage you hopefully get back to the original flame, so you can kind of close your animation loop in a way as well. But if you're modeling kind of human-esque or animal characters, then this seems is the preferred way of drawing it. Okay, whatever. But it's probably not so relevant for us, I guess, but still interesting to know. Please.
For like player models and humanoid figures and whatever, you probably want to have a combination of both, so you don't have like strange animation glitches or artifacts that makes your model go crazy or something.
Elaborate. Can you motivate this a bit? I just want to see the challenge.
Like if you jump, but it doesn't interpolate correctly, so you end up with an arm going like this.
Of course, right.
Straight ahead.
Yeah, but okay. Yeah, okay, that would be the obvious artifact I see. No, the idea is they are still to model in drawing, right? We're talking drawing right now. Still to draw it, but it's basically just your method of how you approach it, right? So are you going straight into in modeling the entire animation, or are you just doing the beginning and the end first, and then having an intermediate action, for example, as the next step here? I don't know, whatever. You know, so you basically have, this is usually considered the extremal point, so you want to model start pose, end pose, extremal point, and then intermittent points and so on, based on timing, for example, and then you fill in the gaps by drawing. That's the basic idea. Of course, if you automate this whole process, and then interpolation can go sideways, that's obviously a concern.
But you feel like you have 3 poses, say you have a 3D model, and obviously you're not doing that frame by frame, but you're doing it with keyframes saying what position the different limbs have.
Yeah.
So would you just have then 3 keyframes, and the time between the keyframes is like calculated on runtime based on how high you jump and how long you're gonna fall until you hit the ground? So you have to both calculate how long you're going to stay in the air before you hit the climax point, and how long you're going to fall down from the climax point.
Yeah, I'm talking about now about automating the interpolation, is it?
Yeah, because say, for example, you have a player and the player jumps up to an elevated platform. Yeah. You're going to be jumping for a while up to the climax point, but you're only going to be falling for like a quarter of a normal distance. Well, for example, if you jump off a ledge, that animation has to be slower because you're going to be falling for a longer time. So to match the end pose with when you hit the ground, you have to calculate how long it's going to take.
Yes, you will need to know. Yes, well, not calculate, or you need to know what the end position is. In this case, yes, calculate, because it's a dynamic environment. Yes, but this would be a matter of timing in the end, right? So you still have the same poses, but you change the timing, right? So meaning the landing pose could always be the same.
Yeah, the landing pose will always be the same, but how long it would take to get to that pose would be different, because you're going to be falling for a higher amount of seconds.
Yep. So then you would just extend this fall here basically, and you reuse frames, right?
Slow down the animation from the climax point.
Yeah. Okay. If you have a set number of frames, right? But later we talk a bit about interpolation, so you can actually automatically, there's different ways of dealing with this, so you can actually produce an arbitrary number of individual frames in between as well.
Yeah, that's what I mean. You have continuous positions of every limb, so how fast the arm moves down is dependent on how far you're going to fall.
Yeah, okay. Yeah.
Like how quickly your leg extends
Right, I understand.
How far are you going to
I understand.
fall.
So you're talking
Because-
about, okay, how the dynamics of the animation in between, right? So how
Yeah,
this
because the
could
game
change.
on runtime has to figure out how
Yeah.
fast that's going to have to happen to match the T-pose or position,
Yeah.
or the pose, the landing pose.
Okay, I understand what you mean.
Like-
Yes.
Like, have I understand that concept correctly?
Well, you're going further than it should be, because it's literally taken from the classical animation problem, where you know starting and end point, and you can calculate everything in between, and therefore draw everything in between. But you're now thinking, okay, how do I do this computationally so I can automatically calculate the poses, right, accurately, right? So, and we come back to that in a second, not in a second, in a few minutes, because there's some different approach that you would take possibly in graphics to deal with this issue. Jonas.
Yeah, and but you realize that you can't create something that just works in every scenario.
Yeah.
You might need a different animation system for longer jumps.
Yeah.
Because it just looks weird when you try to reuse.
Force it, yeah. Yeah, so yeah, that's exactly right. So you have that problem as well. That's why you have different animation paths that you could choose and select from, right? And this repository gets quite big and large to exploit in a for a different context. Then, right? That's in our context here. But in a drawn character, you have one single animation. Yep.
I mean, an example of a game engine, you would perhaps make that Disney model by using exactly what we did with the Prince of Persia animation, where you have a starting set of frames, and you have the middle frames, which are the falling frames, and then you have the landing frames, which are played upon impact. So that's sort of the same idea, because you have both the starting pose, I guess, or starting set of poses, and you have the ending poses as well.
Yeah.
And then you just use them in the same kind of way.
That's right. So yes, it just boils down to in terms of if you really have a long the challenge I think that Jona points out here is if you have really long fall, right? So you don't have enough frames. What are you doing?
Yeah, but you could loop them perhaps. That would work.
Without the standing pose, right? So the falling pose only, right?
Yeah.
Yeah. Okay, I can see what you mean. Yeah.
So you end the start pose, I guess, when you reach the top.
Yep.
And then you start the falling.
Yep.
And then you start the landing.
So you're suggesting breaking apart the whole animation idea, right? So and just composing it depending on the particular scenario, right? Nice. Okay. Yep. Of course. I mean, the flexibility you have it because you would have the individual frames. So it's just your decision of how you actually combine and use them, right? So yep. There was some other concern. A break. That's a valid concern. No, yes, are you dead? I don't know. Too late? I missed the break, no one survived. All right, okay, what is it then? 11:15, else you start buying coffee downstairs and spend all your student money. So.
Okay.
It's different.
It's different one. It's a different one. Two don't really have. Yeah, 2 wallets.